And there we go, we're recording. Thanks everybody for coming. Tonight we're going to have Subash present about universal payload measure boot. But before we get started, wanted to check with everybody, see if there's any opens. And we'll take the resounding silence as no opens. And then what was the future topic you were talking about, Vincent?
Yeah, I think, was it the FDT as an alternative to Hobbs for the payload? I think Li Sheng was gonna lead that discussion. And I guess one open, now that we're doing opens before we jump into the topic is, this quarter we really want to lock down our USF sort of 2022, the 1.0 content, get to a 0.9, and so that's an eye towards some of these topics, or seeing if it makes sense to intercept or we push off to the 1.1. So that's one I think item we want to work with this forum going forward to before the close of the quarter. But but tonight
we want to have that lockdown for version 1.0 release.
Yeah, I think we committed the original and started talking to the community at the beginning of the year, by the end of the year, and we were thinking this quarter sort of, be kind of, architecture complete, and then we'll have Q4 to maybe do any iterations. And so, it's not likely that this FDT topic that we have queued up will make the 1.0, but maybe we can pencil that as a potential 1.1 topic. But things that we have, more surety around, we really want to kind of lock down the 1.0 this year. And so that's where it'll be interesting to see, tonight's topic, to see if it's, something that maybe we could admit to the present wave of specification, or it'll be future looking. But want to sort of set that expectation with folks as we work through the quarter here.
I have that down under opens. Arthur, welcome. Did you have any opens?
Don't have open.
Okay. Thank you, Arthur. Well, then with all of that taken care of, I guess we can go ahead and get started with the agenda for this evening. And Subash, if you want to go ahead and share your screen and go ahead and start your presentation.
Sure, Mickey, thank you. Let me start my presentation. Okay, just give me 1 second. Hello, guys. I would like to, in the universal payload, we would like to introduce the security features. Like I would like to speak about what is the security in the universal payload and all. So, okay. Basically, we are trying to, I'm audible, guys, just I want to know.
Yep, we can hear you and see your
okay, thank you.
Looks good. Yep.
Thank you. Okay. Yeah, we as part of this, just I would like to give a quick overview of the secure boot, like what does this secure boot does. Like it is a pretty common feature in ADK2 and in the bootloaders and everywhere. Just there is the secure boot can be divided into like two parts. One is a verified boot and measured boot. totally we can say it as a secure boot. Like actually, when there is a secure boot, it enforces some boot policies during the boot process. Like actually, this is from the chain of trust to the OS. Whatever the modules we want after the OS, we can extend this chain of trust. Like actually, if something fails in between, the system should stop. That's the part of the secure boot. When compared to when coming to the measured boot, it's like it does the integrity measurements, which are placed into a module called as TPM, which is a trusted platform module. Like actually we measure from starting from the root of trust, bootloader, OS and all. So if something just it measures and it extends to a TPM, that's all. It measure boot never stops. If some hash verification fails or anything, measure boot will not stop. The measure boot is used to check the integrity. Once it boots, we can check with an attestation. Like we can connect to a remote server and we can check the like PCRs and all. So yeah, both of these combines as a verified boot. Like actually, the measure boot is is done with the TCG compliance, like which is a trusted computing group compliance. Yeah, this is the secure boot, like just now, whatever I just said, like if it is like a unsecured system, like actually just it boots and it executes all the blocks and there's no security here. And like if it's like a verified boot or measured boot, like coming to an example of measured boot, when something is, when a block is getting executed and when it is before loading it, it loads to a particular module TPM so that like whatever it's loading, like whatever it's verifying or whatever it's loading, it measures and it extends to a module PCI bank. Similarly, verified boot also same thing. Before loading, based upon the policy, based upon the encryption or like whatever the verification which we do, just it verifies the policies. Maybe coming to the universal payload, like example, like how it is happening in the payload, it's in the real environment. Like example is like a root of trust, which could be anything. In our case, just we took the Intel boot card example, and it loads like a root of trust, verifies the bootloader. It could be a BIOS or a core boot or a slim boot or anything. When slim boot is there, it verifies the payload, any payload. It could be a UFA payload or a Linux payload or anything. Once the payload is there, payload verifies. It verifies the OS or apps. It will be the chain will continue, and at the same time, like we are extending the measurements to the TPM. Okay. Just yeah, these are the universal payload security features, as we just reiterating. So we have to introduce like yeah, today I'm just I will be specifying spec details, like what are the things which are proposed for verified boot. So like verified boot is one thing. Verified boot, once the bootloader has done the verified boot, like payload also can do the verified boot for the next operation. It depends, like in the UFI payload, we can use UFI secure boot. If it is a TPM and enablement of TPM and measure boots in the universal payload, it should be as per the TCC spec compliance. We have to follow the TCC spec compliance and it should be supported for TPM 1.2 and 2.4 and different TPMs, whatever the TPMs which we give. Like it could be a firmware TPM or it could be a discrete TPM, like in Infineon 1 or ST or anything. Any questions, guys? Okay. Let me go into the details. Okay. Like actually, yeah, whatever the universal payload is there, like whatever the universal payload hop, these are the proposed hops for universal payload. Like actually, when the bootloader is passing the information, we expect like bootloader is doing the verified boot or measured boot, and for enabling the in the upper level bootloader, these are the informations which we should which a bootloader has to pass, and it's same thing should be consumed in the payload. Like example, this is the secure boot information hub. I've just said, like one is verified boot enabled, one flag is there, and one is measured boot enabled. One is like firmware debugger initialized and TPM type and TPM PCR active banks. I'll just come here like one by one. Like when you say verified, when you say verified boot enable, like it indicates the verified boot has been enabled in the bootloader. When it is a measure boot is enabled means TPM and measure boot is enabled in the bootloader, it indicates. So that like yeah, when bootloader sets it, like OS also, payload also can do a verification to have a complete chain of trust. As per the TCG spec, when the firmware, when it is a sample part or when it is in a debug mode or manufacturing mode, the PCR7 has to be extended. So bootloader has to pass this information, firmware debugger is initialized or not, and so that PCR7 can be extended. Like based on the flag, PCR7 should be extended with the information whatever the TCC spec says. And there is another thing is TPM type. TPM type indicates it can be like a TPM 1.2 or TPM 2.4, or it can be there is no TPM. Based on the TPM type, okay, I mean to say which drivers to load, like what is a spec to be followed, like there is a protocol difference between TPM 1.2 and 2.0, whatever when we are implementing in payload. Based on this implementation and based on this implementation, this particular and bootloader and payload can dispatch their modules, respective modules. And there is one more information which is required, TPM PCR active banks. One, it's like right now, example, like these are the algorithms which is supported by the TCG standard. It is SHA-1, SHA-256, SHA-384, and SHA-12, SHA-512, and SM3 256. So based on the TPM, right now, based on the TPM which you used, and as bootloader is executed running in the PA phase, and bootloader payload is running in the Dixie type of phase, when we are comparing with the EDK2 and UFF BIOS, it indicates like we have to set some, this information is required in some of these bootloaders. So in payloads, like at least in UFI payload, this information is required. Based on this, we can select what are the algorithms to be active, like whether it might be a SHA-1 or SHA-256. Based on this, number of banks will be activated. Guys, any questions or should I continue?
I think all the approach we defend
So essentially you're parameterizing, if you want to do the measured boot chain, the bootloader ahead of it may have done the TPM start, TPM,
That's
and then
right.
done the PCR 0. And so it needs to kind of leave evidence or information around that generic class drivers in any payload could continue. So you believe this is a sufficient set of data to leave behind what TPM, how it's configured, what measurements were done, what state the machine is. Like if you're in debug mode, you had to extend the debug string into 7. You believe this is kind of a complete data model of all that information that you would have to pass forward?
Yes, there is one more information is like by next hop I would be coming for the event log for at least okay, if for the verified boot, it's independent. Like it's what is a methodology? Like example, when we are saying the verified boot, it can be a UFI secure boot. If it's a UFI payload, if it's other payloads, it depends on that mechanism. Whatever they want to, it is never tied with. As I understand, like it's never tied with. I mean, to maintain the chain of trust, we want this flag to be enabled, but I don't believe there is a required information to be fast
Okay.
from bootloader
Like
to
what was the
payload.
strength, the function of the verification? You're not saying I verified against a hash or public key or how strong. You're just saying I'm doing verification.
That's right.
And you kind of know that it passed verification, else you wouldn't be in the payload because you would have stopped or something. But it says verification is active. Okay, I see your.
Yeah, that's right.
thinking.
Maybe, yeah, maybe at least in the UEFI, if you are sticking with the UEFI secure boot, it is already we would be provide. I mean, to say we are just providing. There is some informations might be required, like in non-volatile regions and all, which are already part of universal spec for the non-volatile variable region, UEFI variable and all. So they can populate the information for the UEFI spec. It will load all the required variables into the non-volatile region. That's the reason. And if somebody is implementing some other verification mechanism, for example, like a Linux payload or something, they can have their own implementations, how they would have, how they would pass the keys and all, like all these things.
It makes
But
sense.
for yeah, okay. But for measure boot, like example, measure boot, we are assuming like measure boot is enabled in the PI phase, I can say, like which is in the bootloader, like bootloader or whatever the stage it is there below the payload. Definitely measure boot and TPM has to be initialized. If TPM is not initialized in the bootloader, we assume that I mean to say the payload, what the payload should not do any operations automatically. If is like a measure boot is not enabled, that means like TPM is not enabled, payload itself cannot start the TPM. It should be started from the TPM startup. It has to be done at bootloader level.
Gotcha, because you don't want the payload to presume it's the CRTM or what the TBB is. It's something ahead of it, and it's just an ancillary later part of your host firmware. So you don't have a default where, if not started, you initialize the TPM. You assume you didn't start the chain, and so okay, I
Yeah,
understand your thought.
because of the chain, actually we want to maintain the chain. So that's why we are trying to maintain the bootloader only. That's to complete the chain of trust.
Makes sense. Okay.
Okay. Yeah, this is a thing. Go, sorry. If we missed you, you are saying something. You
Hello,
could
can
you
you
be?
hear me?
Your voice is little low.
Oh, really? How about now?
Yeah, it's
Better?
getting. Yeah, it's better.
Ah, cool. Basically, I mean, in this structure, at the if you look at the current universal payload spec, every structure will start from a common header. I mean, in this structure, you can also add a common header.
Okay.
We define in the spec. Yeah.
Okay. Sure. Definitely, I will update this interface as per it. Sure. Go.
Okay. Thank you.
Thank you. Okay. As part of the I mean, when we are extending, just I'm going one step back here. Okay. When we are extending this to TPM, like anybody is extending to TPM, there is like a one more thing will be extended, like one value, hash value will be extended to TPM, and the same hash value will be recorded into a log file also. That's as per the like TCC spec. We like every module has to record the event log. So like for example, like when bootloader are extending the event log, there should be some information should be passed to the payload, like because this is a responsibility of the payload to hand over the information like event log to the OS. Once it comes to the OS, OS can verify like whatever the PCR extended and whatever the OS apps, OS is reading the values, whether it will replay the PCR values and it will compare with the event logs, whether both are matching or not. This is one way of verification that is called as a PCR replay. So once this event, I mean, I didn't capture in this event log in this picture, but for that's a log file which has to be passed from bootloader, like whatever the bootloader extends the events to the payload. So, so for passing this like event log, Okay, there is a hop should be created. Like example, like there is a one hop which we are creating. Like each event, like example, like if bootloader is passing 5 events, example, there will be 5 hops of this as per the TPM 1.2 or TPM 2. And these are the hops which we are creating, like GTCG event 2 hop and this one. With this information, like for every one, I mean, this information, whatever the TCC PCR event 2 I'm mentioning, this event information has to be populated from the bootloader for each event, and it has to be passed as a hop so that when this event, when this information is received by the payload can pass this information or like add to the its event. Like payload also adds some events, like the as per the spec, payload also does some events, so it can add the events. So like here there are 2 hops as I mentioned, like one is respective to TPM2, one is respective to TPM1, and I have mentioned the this PCG PCR index and TPML digest values, and this is pretty much as per the spec, which is PCR index is example PCR index. It indicates what is a PCR it is going, and event type, like there are many event types, like it might be a boot firmware or it could be a config file. It is also as per the TCG spec, which bootloader and payload has to implement. And this is a digest. Digest is a hash value. It might be like a SHA-256 or SHA-324 or something, which is a hash value which is extended to the TPM. And this is the event size. Like event size is like a string. What I can say is like when we are executing, like in from bootloader, if we are updating some boot component, like some firmware, whatever the firmware which you are updating, like some UEFI string type of thing, this will also will be passed here as part of it, so that like when we from the OS level, when we are seeing, we will know the reference, what is the event sizes and all. So like actually these are the indexes, like I have captured TCC to PCR index is like it's an integer, and this one is also integer, and this is the TPML digest values. It is as per the spec only, but this is also this has like all the hash counts, like based upon the whatever the hash count which we mentioned, like it can be synced with the bootloader, like how many hashes which we support. Based on that, like all the digests has to be supported here.
And
In-
those
in-
type defs are from like the TCG specifications.
Yes,
Correct.
these are as per the TCG specification. Mostly I captured from EDK2 specification. I believe like this should be same as TCG specification.
Okay, so there's the
Yeah, I'll
TCG
just double confirm.
prefixes are from that spec. Okay.
Yes, from the like these are the prefixes from the EDK2.
Gotcha. Okay.
And especially for each TPM device, it might have multiple events, right?
Yes.
As my understanding, if we have multiple events, they have to, have this event in sequence. So the sequence should be same with the one when you extend the hash to the TPM, right?
That's right, Go. Like, yeah, it's a good point. Like, yeah, whatever the sequence which we are extending, the same sequence, these hops also should be created. Because when we
how
are,
you can guarantee the hub will be the same sequence, since the hub can be any sequence, right?
okay, okay. Does these hops actually, when we are creating a, okay, maybe I have a very basic question. When we are creating a this hop, like a GTCG event to, I mean, when for a one UAD, when we are creating a hop, when we are parsing, I believe it will be taken care in a sequential manner, right?
Okay. You are expecting the first hub we we found from the hub list is the first event we extend
Yeah,
to
that's
TVM.
what I'm expecting. Maybe like yeah, that is a good point. I had to do a check once again, and maybe if the whatever the bootloader is passing the information hop, if it is not whatever the sequence it's passing, if we are not receiving in the same sequence, then definitely it will become a issue. It should be a same sequence. Whatever the we are extending to PCR, TPM PCR, event log also should be extended in the same way.
Yeah, Vincent, do you remember for this hub, we really have a sequence requirement?
Yes, we have. We should.
I mean, in the hub definition, at least potentially they could change their hub sequence when they, I mean, copy or change the hub list.
Yeah, I think in practice it's an append-only structure, and if you want to delete one, you sort of mark it as deleted in place, and then people can the hub is supposed to be address invariant, meaning you could like copy it, but I think assuming it's in create order is probably okay. But we should specify that more strongly if we have any program logic dependent upon it. But in practice, people don't reorder the hob list.
Yeah.
Yeah, it's
Okay.
just I think the only thing I remember people doing is maybe moving it like, hey, PEI had allocated memory location X for the list, and then the later code can move it to an allocation, you know, higher in the near top of low memory or something. But I think I think a creation order is probably appropriate to assume.
Yeah, and this hub is not really defined by the spec, right? It is our implementation choice of the indicator, right?
Yes, it's an implementation choice. Like this is how. Okay, this is where we are trying to at least leverage the existing EDK2 implementation, because we start in the Dixie phase for EDK2. So what we do is like if we publish this hub, like whatever this hub is getting created, so automatically like the same hubs are getting created in the PA phase also. So in the EDK2 implementation. So if bootloader also it creates it, automatically existing EDK2 drivers can consume it as it is.
Yeah,
Yeah, and I think
yeah.
and
Yeah,
I think
but
I think the discussion here is, can we graduate this implementation practice to being architectural, i.e., you know, these generic state variables that would work for any payload, because you know we cheat a lot even in EDK full BIOSes where we know we sort of match a TCG PIM with a TCG Dixie driver, but if we really want this bootloader invariance, we need, you know, a well-defined contract. And so, you know, thinking yes, Vash, the point of this is we could say, could one of these implementation practice hubs become quote architectural, so we could, you know, replace the bootloader on the early boot, or maybe the payload if we didn't do EFI payload but used a Google depth charge that also does measured boot. Could it, you know, evolve to this? Or, you know, if Linux boot is doing a static chain, could it use it? But yeah, I believe, yeah, with the starting point is implementation practice, but could we kind of graduate these implementation specific hubs to architectural would be kind of the hope of this evaluation we're doing.
sure, definitely, because these hubs are pretty much like as per the TCC spec. Because as I see, after putting Grub also uses a similar implementation, because right now whatever the bootloader extends to an event log, to the same event log, Grub also extends. Grub and shim layers. So this is pretty much standard. I will double confirm it and I will let you know, Vincent. This is industry standards or how it is if there is a deviation.
Yeah, if it is not an industrial, standard defined by spec, potentially we could use one TPM structure, TPM2, I think event log can back compatible with the 1.2 event log. Use one structure.
Okay.
It's good enough, basically, if we really want to define a common structure.
Sure. One more basic question I have, Vincent or Gao. Should we, because TPM 1.2 is almost getting deprecated, right? So TPM 2.2 is the advanced standard. The universal payload, should we still support TPM 1.2?
I think technically it should, even when we define some structure for the TPM, right? Not start to TPM2 or TPM 1.2, potentially might have TPM3, for example, right? For the event, yeah, we try to make it more generic, I think. At least if someone want to use TPM 1.2, the structure should be able to support it.
Okay.
That's my understanding. Yeah.
Yeah, it's an interesting question. Yeah, because we're doing house cleaning here, and if this is quote the new approach, could we make the assumption it's TPO to M2O? I think it's worth evaluating, and maybe as we go forward, we can even add that as a review comment where we solicit additional community response. But yeah, if it's a low cost and low complexity, more compatibility is compelling. But if we can simplify things, yeah, I think dropping SHA-1, dropping TPM 1.2s, if we can sort of be more of a modern boot flow, that's interesting discussion point to maybe at least we should cycle around as we review this if we go forward. Yeah.
Okay. Yeah, sure. Let me, I will check and please, we can discuss TPM 1.2 implementation. That should be fine. Okay. And next, just I have done a quick POC type of stuff on the universal payload implementation. With the existing UFI payload or universal payload using the UFI payload and the slim bootloader. So this diagram depicts the how that information, whatever the information which is getting passed from how the information is getting passed from the bootloader to this one. So this is in the slim bootloader. We update, like actually there are two ACPI table files, like one is base TPM information and one is information for the physical presence requirements. So when a bootloader consumes just both this information, because it's a common bootloader, so and whereas like when you are using the UFI payload, this has a capability of publishing this one in from the Dixie phase. It's the same tables are getting published. So what we do is sorry, this presentation, this slide is like little out of date, but I want to know like secure boot information, whatever the hub I have provided, and this is the hub information, whatever the hub I have just few minutes back, which we have discussed. Like all these hubs should be populated, and once this hops gets populated, like if bootloader in this once the payload comes, there is a bootloader Dixie phase driver is there. Bootloader support. It sets the firmware PCD and it sets the PCD hash mask and PCD hash mask. And like actually what I meant to say, like once it is there, once this driver is just done, next is TCG to Dixie driver where all the event log buffer and all will be there. It will use the event log buffer And what it does is it will use the information, whatever we have published from the TCC PI hub from here. This information will be populated, will be used here, and it will populate some other PCDs, which is required for the updating TCP table. Once this TCC is dispatched, TCC, there is one more module coming up, like TCC to ACPI table, which where we have to do a new additional implementation. We have to uninstall if there are TPM tables which are updated from the bootloader, uninstall from the system tables, and update the TPM to TPM to whatever the required TPM to ACPI tables, so that like at least in the UFA payload, what we are trying to do is like to minimize the core implementation changes. So like he has mentioned here, like bootloader support, this is a try, yes, it retrieves some hub information and sits the PCDs, and TCC takes it, creates the event log buffer, and this is this just installs the new TPM2 tables, whatever the populating the information, like whatever the, it will add just TCC to be, this hub will be added into this, whatever is there in the this box, valid box, and next is updating. Rest flow is same in the as per the UFI payload spec changes. Yeah, this is pretty much about the interfaces and a quick introduction about the security hub changes and all.
Makes a lot of sense. Well, one other question on, as we armor the boot process, when we did the threat modeling, we observed that, rogue DMA devices could attack your CRTM and your measurement process. So some implementations do things like turn on VTD, maybe use PMR during the early phase, the PEI equivalent, and then in the bootloaders, maybe even use VTD. Is that something the Slim Boot community has done? Have you guys done VTD protection during boot?
Currently, ideally, I mean, Gao is a better person. Gao, could you just let us know? Yes, I understand, no, but could you say like VTD or PMR ranges, like IOMMU protections are enabled in Slimboot?
Yeah, Slimboot, I think currently it's not enabled. Yeah, VTD, also TSC is not supported in Slimboot. But yeah, potentially we could do something here in Slimboot.
Gotcha. Yeah, and I'm only thinking from like maybe a design pattern approach is we could also look at maybe other if we're maintaining the chain, we're fabricating these data structures so that any bootloader can tell any bootload payload what it's doing. I'm wondering if we like do any self-defense protections like IOMMUs. It's worth evaluating in the future. Because again, it's all about threat modeling. If you're doing measured boot and secure boot, you need to make sure you're doing signed updates. Some folks are now again worried about malicious DMA attacks, so attacking your measurement code. Maybe additional hobs could be sort of a. We could look at some of our present practices, whether it's host-based memory protections like page tables or the IOMMU work, and maybe have an additional hobs, which are, the early bootloader can say, I'm defending myself this way. Like I set up an IOMMU, and then the payload could say, I should continue. And on, Intel platforms, it could be our, generic VTD driver that consumes it. Could be a future topic we look at, but I think modeling it around this critical use case first, sufficiency of both the measurement chain and describing the TPM device is probably the first one we should close, but maybe after we do this, we should think about other sort of, self-defense technologies, active during the boot phase, so that if people want to do measured boot and say, hey, but I want to, I'm worried about, rogue device attack, then we can say, hey, there's provision if your initial bootloader does self-defense, it can describe what it's doing such that the defenses can have some continuity in the payloads. But that's probably that'd be a future looking thing. But yeah, I think this one's such a critical use case. Most DFI systems, they assume secure boot, measured boot. Getting this one right first is probably the most important.
Vincent, just to let you know, like I mean, just to answer, like related to VTD, this PMMR and PLMR, it will be like a PEI phase work, and once it is there, in general, in the Intel platforms for our client platforms at least, and it's like what is happening is like. Next DMA remapping is happening from the Dixie phase onwards. DMA remapping. I think we need to extend DMA remapping in the payload also, if you are following the VTT spec.
Gotcha. Yeah, it makes sense. And we have to accrete that as the capability driver. Okay. Yeah, I see your point.
Yeah. Any other questions, guys, related or any feedback on this?
Yeah, for this, flow, potentially if we define the standard interface for UEFI payload, potentially we could change the TCG to DSE driver directly to consume the hub we defined in the spec instead of create a new module bootloader supported TCG DSE, right?
Yes.
Yeah, this is the implementation detail. We can refine maybe lately. Yeah.
Sure, definitely. This one, this one definitely will there. Whatever, just to answer, like whatever the spec, I mean, I just draw this arrow to the flow, but whatever this information is there is how this is getting consumed directly with TCP Dixie. So that's the thing. And whatever the information, secure boot information is there, it is getting populated here in BL support. Yeah, we can use the existing driver and we can populate all the required informations here.
Yeah.
Sure. Thank you. That's all, guys. Thank you. Thanks for providing
This
this
is great.
opportunity.
Yeah. And as Gao's feedback about making it look like the other UPL data structures, the common header, and then in your ACPI uninstall issue, I need to reach out to the maintainers and see if we can get the dialogue going on maybe making the upstream sort of ready for this proposal, in anticipation of us landing this. But I think this is a great direction, and thanks for driving this thing. Great architecture flows, and then a POC, so it's not just as Andrew Fish used to tell us, if he only had a PowerPoint to C converter, well, you have the PowerPoint and the C code. So to me, that's always where the ground truth is. So thanks for doing this.
Thank you, Vincent. Thank you all.
Thank you, Subash, for coming on such short notice.
Hey, thank you, Dimik.
Yeah, it is a good start point. We have verifiable and measurable. Literally, we can add more maybe security related feature, for example, MOR or some other.
I didn't think of MOR. Yeah. That's a good one too. Yeah, we can go look at our grab bag of plot security features, and we've done the cheats where people who own the whole code base could make some implicit assumptions. Maybe we can surface those assumptions through the Hobbes in the same spirit as Subash done here. Yeah, that's another good one. Go. Yeah.
Well, great discussion. Thank you for the great presentation. There anything else anybody? Okay, I am going to officially stop the recording.